this video, we'll look at the issue of performance of robustness. Alright, robustness performance, or another word. Somewhat of a video to prove that s plus t is equals to 1. Alright, so we are somewhat going to prove to it, then we see whether can we really prove to it. Alright, so let's start. In the previous video, we know that the control sensitivity functions is equals to c over 1 plus cp naught, where this is somewhat relating to the input to the plant, right? And also, it can be further identified as c times 1 over 1 plus cp naught, which is s naught. Alright, where s naught is over here lah. Okay, now what is actually y over r? Y over r, if you remember, this classical block diagram over here. We dissect it, right? We say that we ignore ds and ns, we ignore the disturbance and the noise, and therefore we have this. Also with that, we have the reference signal, we call it a command response, or we multiply with the f. So if we were to solve in terms of just the command response, what we will have is the rf, alright, r times the filter, multiply with cp, alright, 1 over 1 plus cp. Cp 1 over 1 plus cp, yeah, cp over 1 plus cp, yeah, cp over 1 plus cp. But anyway, equals to output y, which is over here, right? And therefore, if you were to rearrange, right, if you were to bring this r downwards, what do I have? I have y over r is equals to f times 1 cp1 plus cp, where this dude over here is actually t. Alright, so if your plant is your initial plant's p naught, and therefore this is just t naught, because the rest is just p naught, and the end is still t naught, something like that. Alright, and therefore this is also shown over here. This is t times f, the filter. Alright, where we can also be shown over here, where this is the t, and this is also over here. What is the purpose of me doing all this stuff? Why do I want to show you this? It's because SU, as you know, is over here. Alright, this is P, this is the plant, this is the controller. So U is here. So SU is with regards to the input into the plant. Alright, which is a very critical step. Alright, then the output Y with regards to the command response R, or reference signal, alright, is also in terms of T in this case. Alright, so the input is in terms of S naught, the input to the plant is in terms of S naught, while the output and the reference signal or the command response is with regards to the T naught itself, as you can see. Alright, so therefore all the parameters, the input, alright, the output and the input to the plant, or in another sense containing the information on C and the error E. So every information on here can be represented in S naught and T naught. That's just what I want to mean. What I want to convey. Alright, and therefore if P naught were to change, alright, because C is something that we have already control, something that we can own self do, but the plant itself is something that we need to really analyze, because the plant may wear over time, may actually spoil over time. So as the plant changes, things will actually change. S and T, alright, may actually change also, and therefore this S and T change will also influence your input to the plant, and also will also influence your output and your command response all in one. So just the plant itself could actually cause all of these troubles. Alright, and therefore how do we actually analyze things such that we can actually give our understanding of S plus T is equals to 1. From that, then we can understand fully how is this relationship come from, some sort of that meaning. So in order to do that, if P naught change, because we know that if P naught change, S naught will change. So we're gonna do some of an equation that when P naught change, S naught will change, something of that. So therefore, let's write the relative change in the S naught, alright, due to the relative change in the P naught. What does this mean? So there will be a small change in the P naught over here. Maybe I should write in red. A small change in the P naught with regards to its original P naught will incur a certain small changes in the S naught with regards to its own S naught. So this is what is trying to mean, and this is what we are going to do, right? Because certain changes in the plant will incur certain changes in the perturbation of the S, right, or in the disturbance of the S itself, and therefore which is equals to, so when we rearrange this system, we'll get this one. Alright, just simple math. Alright, just take this one, divide by this one, most likely you'll get this one. Okay, so once you do this, alright, you can see that this is actually a differentiation. Alright, it's like dy over dx, some sort. So S0 is in fact the y, so it's somewhat d over dx. So it's the analysis of y with respect to x. In other words, S0 changes with respect to P0. Alright, so therefore we're going to differentiate S0, and this is the case. So differentiate S0 with respect to P0 is equals to 1 over 1. So this is actually S0. Alright, S0 I can rewritten as this one first. I just inverse 1, that's all. And then I differentiate this one, I bring down over here, and then this C I also multiply out, which is shown quite clearly over here. So be careful that you're going to multiply the inner function also. This is very tricky, so you have to be very, very careful about that. And therefore you have this one. Alright, and we place this answer over here. So far so good. Now we're going to elaborate this one. Alright, 1 over S0, which is this. So this is S0, although it is S0, this is actually 1 over S0, right? So we know that S0 is this one, so 1 divided by S0 is 1 plus Cp, right? So 1, because S0 is equals to this one, right? So 1 divided by S0, this is holding is S0, so therefore it will give us 1 plus Cp0, that's all. Right, so it's over here. So far so good. And then P0 multiply by 1 plus Cp0. Right, I will not go into multiply it in, because please do not multiply also, because you're going to make things more hairier. So I'll just keep it like that. And I rearrange this one, because it's -2, I just bring it down over here as a fraction. So this thing over here. Alright, now I can cancel what? Cancel 1 plus Cp0 with this, because this is 1 plus Cp0 square, so I can just cancel away the square and that's it. So what I will have is minus C over 1 plus Cp0 times P0, which is what we have, over which is minus Cp0 over 1 plus Cp0, which is equals to minus T0. And what does this result tell us? Alright, is that when P changes, alright, S0 change. Correct, and this changes actually causes, when P0 change, that actually create a certain changes to S0 such that the outcome is a minus T0. Okay, never mind. In other words, if S0 increase, if there is a change in S0 due to P0, then there is a decrease in T0. That is just what it means. So if S0 increase, T0 decrease. Alright, that's just totally what it means for the whole equation. Alright, so we're gonna prove for the T0 itself, such that if it's that case, alright, if they are actually proportional or inversely proportional. So therefore, previously we do for the S0 itself, we say that relative change of P0 will give a certain change of S0 that would, if an increase of S0 will actually create a decrease in T0, some sort of the meaning. So now we're going to analyze in terms of T0, and therefore we write the same thing. Alright, the P0 itself over here, it's a small change of P0 will give a small change of T0. Alright, with respect, so relative change of T with respect to relative change in P. Alright, some sort of the meaning, which is equals to, so I rearrange in terms of math. Now I have this thing, we know that this is a differentiation, and we know that T0 is equals to this one, and therefore I can simply write this thing as this one, because it's just inverse minus 1. I'm just rewriting the terms. Alright, and therefore this one I differentiate. So I'm simply, this one is simply to tell you to differentiate this one. And therefore if I were to differentiate, Alright, because I want to go through with you this because there's a careless mistake that I've done. So therefore, minus 1, which times Cp naught, which is Cp naught, 1 plus Cp naught, minus 2. Alright, and then multiply the inner function C. Correct? And you'll be tempted to go continuously with the other stuff. Alright, but please take note that there is actually two systems. It's a product rule, it's a P naught and a P naught within it. So you cannot just do one time, because what you are doing now is actually doing this only. So this is a very prone to careless mistake. So the extra step you're gonna do is that, so just now what we have been doing is actually to keep this one, we differentiate this one. Right? So now we're gonna keep this one and we differentiate this one, and therefore I have plus C over here. And also multiply with 1 plus Cp naught minus 1. Okay? So when I rearrange this term, I will have this one. If I rearrange this term, I will have this one, because I'll just simply change the negative 1 to a fraction. That's all. So therefore this term over here is equals to your differentiation over here. And then multiply by your P naught over your T naught, where we know that T naught is equals to this one. So 1 over T naught is simply flipping over the other side. What we have is this one. So this term over here is simply 1 over T naught times P naught over here. So it's equals to this one over here. Alright? Well, I actually put this one over here also. So now how do we do stuff? If you were to multiply it, then you're gonna kill yourself. Alright, you're gonna make things more hairier. So what I can do is actually to do something with this. Alright, because it's just some fractions. So I'll just simply multiply them by this. Alright, so I'll just simply multiply 1 plus Cp naught over there, so that it is the same fraction. Alright, if that's the case, minus C square P naught over here, plus, I'll just multiply it in, I'll have C plus IC times C naught, C squared, now is C square P naught. Alright, over 1 plus Cp naught square. Okay, so this whole thing is this one. I mean this whole stuff over here. Then I'll just simply pull the rest down over here. I'll just pull them down over here now. Just copy and paste only. Now, then we can do something with this. Haven't yet. Alright, so so minus C square P naught plus C square P naught, what is it? They're actually cancelling each other. I actually forget to cancel before I go and cut. Anyway, so now we have this one. Wouldn't it be more clearer that P naught and this P naught can be cancelled, and this C and this C can be cancelled now, because this stuff has already been cancelling each other. And then 1 plus Cp naught cancel with this one. What do we have? 1 over 1 plus Cp naught. Ta-da! And it's equals to S naught. Ta-da! And therefore this means that when P naught is changing, that changes T naught, alright, it will actually instill an increase of S naught. Alright, so if T naught increase, S naught increase. Alright, from the other case, when S naught increase, T naught decrease. So what is it all about then? And due to some magic, alright, this thing is later on derived as this one. I don't know why. I think they derive into this because this is the only true case such that S plus T will be equals to 1. Right? So we're actually missing a link between this stuff to the reason behind why is it S plus T is equals to 1. Because for this case, this will actually use this form. Or in other words, if S increase, T must decrease. Alright? But however, in this case, if T increase, S increase, then what the hell is going on, right? So I think due to a certain trial and error, they actually deduce that this case exists more than, or maybe this case, both cases exist, but just that this case exists on a certain part, alright, that they actually discuss. But at the end of the day, you still need to know that S plus T is equals to 1. Okay? I believe you have understand this thing based on our beginning part, where we say that performance is determined by ST, SU, and TF, which is SU, TF, S, and T. Right, this is the performance is determined by all this stuff over here, and we further say that TF is represented by T, while the SU is represented by S naught to a certain extent. Alright, based on the understanding, we run a trial such that a small change of P naught will give a change of S naught and T naught, and then we derive all the differentiation and stuff, and therefore we somewhat state that S plus T must be equals to 1. And so forth, if you want a robust S, meaning you want S to be very large, then we need T naught to be small. So if S increase, then T naught must be decreasing. Alright. But however, on the other hand, if you want T naught to increase, then your S naught has to be decreased. Same thing. So robust T, we need S naught small. That's just the meaning of that. Right. And then this is also the case such that normally S is more at low frequency, because we know that S is a high pass frequency, high pass system, and T is a low pass system. So at low frequency, S is small, T is big. Alright, conversely or inversely, if the frequency is high over here for S, then the S is dominant, and if it's high frequency over here, T is actually lousier. So these are the relationships that we have discussed and should be sinking into you quite readily. Alright, that's just the meaning of it. Alright. And lastly, we would like to say that this little small changes of P naught, alright, that changes the small changes of S or small changes of T is called the nominal changes. Alright, where you have a very small changes that have occurred. Alright, and this nominal changes is analyzed using S and T naught as we have said, and therefore in the next video we'll talk about another method to actually denote explain this phenomenon. Alright, and let's see how it goes. I shall see you in the next video.